Howdy everyone, my name is Prasanna and today I'll be walking you through the work I've completed as a part of this Milestone project. Here's the agenda of today's session. First, I'll explain how I did the environment setup using AWS EC2 and FileZilla. Next, I'll describe how I authored and executed SQL scripts that creates the database tables, loads data, and even cleans it. After that, we will go through the ingestion process which I performed using EDL. Finally, I'll dive into advanced SQL features such as views, virtual columns, stored procedures, and UDFs, and wrap up with role mapping and security in MariaDB. So let's get started with the demo. For launching an EC2 instance, firstly you have to name an instance, select Ubuntu, make sure it is Ubuntu Server 24.04 LTS. Then we need to create a new key pair for pairing your FileZilla with the EC2 instance. I have already did it and downloaded the keeper here. And yeah. Lastly, for downloading, installing MariaDB into your server, I have used this automated script, and this is how instance looks like. Make sure we have installed MariaDB. Okay. Nextly, we'll connect our FileZilla to our EC2 instance. For that, we'll have to go to Site Manager. We need to provide the public IP and port number, that is 22 for SFTP. Name your user as Ubuntu, and here you need to provide the key pair that you downloaded from EC2. Just hit connect, and you're connected to the EC2 server. We'll just see. Okay, I have downloaded the CSVs using an automated Python script and directly uh, fed them to the FileZilla application. Let's make sure all the CSVs have reached our server. Oh. As you can see here, the CSVs have successfully reached the server. Moving forward with the script authoring. I authored the SQL script directly on EC2 server using vEditor. I have used ETL approach for the same. It began by creating a database, basically including a drop table uh, query that I'll show you in the table. Nextly, I created seven tables and defined them as customers. I'll show you directly in the query that I have used. So yeah, here's the drop table query, and I have created seven tables, that is customers, categories, suppliers, products, orders, order items, reviews. I used local data, local in file syntax for command in MariaDB to load the data into the tables. Finally, I enforced data integrity by adding checks such as checks on dates, applying it, email regex validation, and ensuring numeric values were properly formatted. Here it is. I have let regex validation here. So let's make create a database on MariaDB. Copy the script. We will use vEditor. We can name the file as persona.sql. Sorry. And we will paste SQL script. And yes, the script has been saved here. After that, we will use this bash command to make a database out of our script. As you can see here, the database has been created, namely Zepto. Now let's make sure that all the content in our database is present. We'll use select count query for that. Let's check for other tables as well, like products. Yes. So our database has been created successfully. Moving ahead with advanced SQL features like views, virtual columns, procedures, and UDFs. I created several analytical views here. For example, product view combines information about products, categories, suppliers into an easy to query virtual table. Other views also included customer, order, and review summaries. Each of them were crafted to streamline analytics and reporting. Moving ahead with virtual columns. I have created a virtual column called full name that combines first name and last name of the customer. I used the alter table customs query. The key benefit of virtual column is that they don't take up extra storage. Instead, they are computed on the fly whenever queried. This is the syntax that I use for querying a virtual column. Moving ahead with stored procedures and UDFs. I implemented a stored procedure, clean product names, which trims and standardizes the product names. This procedure can be called anytime and the product data needs to be refreshed. Additionally, I defined a user-defined function called normalize amount to automatically handle and clean the numeric fields. This database features centralized data quality rules and automates routine corrections. Lastly, role mapping. For security, I established role-based access control using MariaDB roles. There are three main roles that I assigned mainly, that are admin, DataOps, and read-only. Admin for all access, including management for myself and root. DataOps for operational updates and business entries. Read-only for reporting and analytics. Users like Prasanna and employee and reporter are set up and mapped validated in the rules mapping table here. This is the script that I use for rule mapping. Here, as you can see, all the privilege on our Zepto database have been granted to admin, that is me, Prasanna, and the employee. Sorry, the root user. Now let me walk you through how I used GenAI in this milestone. For this project, I relied on ChatGPT Pro. It supported me mainly in three areas. Firstly, it helped me with SQL syntax for database schema design and more advanced SQL techniques. Second, it provided explanations that strengthened my understanding of SQL statements. And thirdly, it was useful for debugging, of course, and correcting SQL syntax errors when things didn't run as expected. Of course, I had to make corrections to the AI generated output. For example, I removed unnecessary extra columns during table creation, and I also rename certain columns so they match my dataset correctly. Overall, from this process, I also learned a couple of more important lessons. I realized that multiple reprompts often led to more reasonable responses, and that the clearer and more precise my prompts were, the better the AI's output turned out to be. So, overall, using Gen AI gave me a head start, but refining its output and applying my own judgment was critical in building reliable solutions. This was all for my milestone one. Thank you for watching.